So this is complete list of categories and sources of emissions and which species and which category are emitted. So that was the idea. And where do we start? Next slide, please. We thought what are the main methodology sources of information, methodologies, framework, and we identified three of them. It's IMAP EEA Air Pollutant Emission Inventory Guidebook, former Coronair methodology, US AP 42 compilation of air pollutant emission factors, and UNEP manual on atmospheric brown clouds emission inventory. So we try to analyze these sources of information and trying to discuss it with experts. Maybe there is some categories that sort of underrepresented in one respect or another, and which species we're talking about. So the idea was that this analysis will be the basis for the first and expert meeting, which was held in October 2021 in online format. And all of we experts considered all these technical documents. We prepared tables on all sources of emissions. And at the end of the day, this expert meeting provided this complete list of SLCF sources. And also, we're thinking what are the main knowledge gaps in developing future guidelines for SLCF emissions. So this also during in the groups in different sectors, these knowledge gaps was discussed. And we published a report with all this supplementary information on our website. And I will show you next slide, please. Just a small example how we created the table. For example, there was ammonia production. This is a possible SLCF emissions. Whether we can use IPCC method or if it's not applicable method, what is our alternative methodologies, what are available emission factor parameters, if it's globally applicable, if any gaps, and any comments from the experts. So it was a quite extensive work on that. We studied a lot of materials and so on. And at the day of the day, we come up with a category list. Next slide, please. Just one thing I need to clarify, probably from the very beginning. When we're talking about short-lived climate forces, we're talking about the following species. It's like NOx, CO, and VOC, ammonia, black carbon, organic carbon, but we did not consider methane and F gases because they are already covered in 2006 IPCC guidelines. So new methodology report will not cover methane and F gases. Some they're considered to be short-lived climate forces. F gases, some of not very short-lived, but some of them can be. So then we did a third expert meeting. That expert meeting further identified all this information from the first and joint meeting. And also we discussed cross-cutting issues, general inventory issues, what are applicable for SLCF inventory, what is not. For example, key category analysis, all the metrics that we can use. And also we took contribution from Working Group 1 and Working Group 3 into consideration, discussing various aspects of SLCF inventory. So the meeting was held in 2022. And that was three topics of discussion that I mentioned. Again, the report is published on our website. Next slide, please. So, yeah, a bit of details. The literature showed us that the most black carbon and organic carbon emission estimates derived from particular metals 2.5. So, for example, emission factor, there is an estimate of PM 2.5, and let's say 20% it's a black carbon. So we need to think how we need to present these emission factors in the future guidelines. But we considered that a lot of literature published in this respect as a portion of PM 2.5. So also we discuss in VOC, it's a big group of species and how to present it by particular species or in total. And experts consider that the total mass of volatile organic carbon should be presented as emission factors. We thought is any priority to one species towards other or not, and the meetings and the experts decided that all air pollutants or all SLCF species are we need to prioritize and to provide estimates for them. The next conclusion was that it is not recommended to use metrics to compare long-lived greenhouse gases with short-lived climate forces. Thus, we cannot make a key category analysis as we do in classical 2006 IPCC guidelines. We convert it with GWP in CO2 equivalents, and we do category analysis. Now, probably we need to do key category analysis species by species because it was difficult element of this comparability. And then there is a big paragraph. So the sources of SL7 emissions are very variable and depends on many factors, on environmental conditions, social, temporal resolutions, and so on. So of course, we will deal with national inventories. But if we have some other disaggregation by regions, by specialization, by seasonality, that may give us provide more accurate estimates. Next slide, please. So again, we did this preparatory work during previous cycle. All these materials are published, a full list of information provided. We've got this complete list of categories with all respective SLCF species. And this input should help us with the scoping process. Next slide, please. Yes, so this is just an example of a category list of energy sector. You can see we put all the species, all the sectors and categories. Next slide, please. And during the third cycle, there was on the black carbon here, yeah. So we also discuss each species, what is measurement, what is definition, what is measurement methods, what is reference, so that to be on the same page that we're discussing the same species and the method of their measurements. And next slide. And this is our reports. So yeah, you can be familiar with these reports if you download them at our website. And then I'm coming next slide to the future. So somehow you may not be aware of how we produce methodology reports and what the IPCC cycle for production of methodology report. So first of all, start clicking. Yeah, so we need to organize a scoping meeting. Scoping meeting will provide a table of contents, terms of reference, and a work plan. We already sort of made a call for nomination of the participants, and we already scheduled the meeting. I will tell about this later on. Then Task Force Bureau considers this outline, which was produced by the scoping meeting, and will forward this to the IPCC session. IPCC session needs to consider this outline, approve this outline, and then we send a call for nomination of the authors. Hopefully it will be this year. And then TFB needs to select authors, and we need to start a first lead author meeting. So all the lead authors will come together and we'll start producing drafts. Zero order draft, first order draft. So lead author meeting 1, lead author meeting 2. And after that will be expert review for 8 weeks. We send in these drafts to experts and receive many comments. And then authors consider these comments at the third lead author meeting and producing second order draft. Then it is sent again to governments and experts together. And then again, second round of this review process. And at the end, final lead author meeting 4, when the final draft produced, and then it is sent before IPCC session for the government review. And hopefully at some point of time, we will have approval and acceptance of the report. And it usually takes like 2.5, 3 years, depending when you start this scoping meeting and so on. Okay, next slide, please. Yes, so at the IPCC 3bis was decided that the scoping meeting was moved from IR6 to IR7 cycle. The nomination letter for scoping meeting was sent by IPCC Secretariat to IPCC focal points and observer organization on 5th of May 2023. TSU collected all these nominations by end of August, and in November, TFB, Task Force Bureau, considered this list, selected participants, and we sent the invitation for participants in November 2021, 2023. So the scoping meeting will take place in February in 2024 in Sydney, Australia, and we're working hard to prepare this meeting and consider various materials. Next slide, please. So what are the tasks for the scoping meeting? First of all, we need to decide on the title of the report. What is the format of this report? What draft terms of reference, table of contacts, work plan, and instructions to experts and authors. So all this outcome will be considered by TFB in order to make a proposal to IPCC panel. Next slide. So this is example of 2006 guidelines table of contents. So you see it's pretty kind of short. There is only main bullet points. What is a volume name and chapter's name. So this we need to produce, and this is one of the main products. It's only, of course, exceptions. There are other volumes like AFOLO and waste. Next slide, please. And this is our plan for the next cycle. Of course, everything depends on that approval plenary session. If it will be earlier this year or later this year, can we manage to make first lead author meeting this year or not? So in January, as Takeshi mentioned, will be IPCC plenary that will decide on the work plan and the next IPCC approval session. And depending on that, we will do all this process of calling forces for nomination, making meeting, having a review, and finally will be adoption. So I guess this is the end of my presentation. If you have any questions, I am more than happy to answer all of them. Thank you very much.
Thank you very much, Pavel. Maybe I think we're good on time. Maybe we can take one or two questions for Pavel right now. If you can raise your hand. No questions? Yes, please.
So hello, good afternoon. So what's the main difference between the IPCC 2006 and the IPCC 2019 guidelines regarding the greenhouse gas calculation?
Well, I mean, 2019 refinement just refined certain areas in 2006 guidelines. For example, in energy, it was only fugitive emissions were refined. In industrial sector was like nitric acid, iron, and steel. So it was not complete overhaul. We analyzed what is a new science, new emission factors. So only particular areas were refined according to 2006 guidelines.
So will not affect the final calculation.
Well, I mean, you can use some information and maybe better emission factor, and it will be more accurate. So it's a better knowledge there. Yes.
If I may, it is not a standalone document. The 2019 refinement need to be used together with the 2006, cannot be used in isolation. Just a clarification. It was Sydney, but it's Brisbane, the city for the scoping meeting.
Brisbane.
Now it's Brisbane, yeah.
Okay.
Thank you. Anke, please.
Yes, thank you very much. For at least for some short-lived climate forces, I think you do not have a global distribution in the atmosphere as you have for the other regular greenhouse gases. And my question is, how are you going to deal with this specific particular aspect of the short-lived climate forces? Because this, I think, is a key difference to all the other gases that we have in the greenhouse gas inventories. So I would be very much interested to know how you think about this particular aspect.
Yeah, they are not well mixed gases. Yeah, it's not about us, it's about the author. But in the expert meeting, we discussed the needs to have maybe a disaggregation in terms of time scale and also in terms of geographical disaggregation within the country where the emissions occur, because there is much difference if they occur in winter or in summer because they react. And there is much difference they occur, I don't know, in the coastline instead of the mountain. So yes, likely there should be a higher level of disaggregation in terms of space and time of this emission than the normal CO2, because CO2, wherever is emitted, is fine. But for those gases, it's not the same if they are emitted here, in Italy, in Japan, in summer, in winter, and so they have a different impact.
Okay, I think we should move on. Thank you very much, Pavel. Next, we'll move on to Sudan with the EFDB.
Okay, good afternoon. And let me present from here because the remote control is not working from there. Sorry for sitting. And so IPCC emission factor database, EFTB, is one of the IPCC tools for national greenhouse gas inventories. So it was launched in 2002 and developed and maintained by IPCC Task Force on National Greenhouse Gas Inventories. So the FTB is an open database, contains emission factors and other parameters that can be used for estimation of national the greenhouse gas emissions and removals in national greenhouse gas inventories. So quality of greenhouse gas inventories depends on the reliable emission factors and the activity data. So FTB aims to disseminate the most recent scientific information on emission factors and parameters. So FTB contains the data from various sources. For example, default data from IPCC guidelines, and also contains data from peer-reviewed scientific papers, data from other publications such as national reports, for example, national inventory reports submitted under the UNFCCC. So in addition, the FTB also serves as a communication platform to share data information among inventory compilers, researchers, and experts. So as Takeshi mentioned, it also one of the source of data and information for authors when developing IPCC guidelines. So the FTB is well recognized as a useful resource for inventory compilers. So it is referred to as a source of, one of the potential sources of data information for national greenhouse gas inventory, referred to in the reporting guidelines, UNFCCC reporting guidelines for national greenhouse gas inventories from Annex 1 parties. So, So we have been updating the database regularly with new data. So FTB is open to any data proposals. So all data proposals submitted to the FTB are considered by the editorial board for inclusion into the FTB. And we have 46 members on the editorial board who are experts nominated by governments and observer organizations and selected by Task Force Bureau. So in considering data proposals submitted to the FTB, editorial board looks at robustness and applicability and documentation of the data. So I just wanted to here note that consideration of data proposals by editorial board is not full scientific assessment of data, of the data source. The aim is to identify data useful for national greenhouse gas inventories. So here the figure shows how we populate the FTB. So all default values from IPCC guidelines, 2006 guidelines and previous guidelines are included in the FTB. And we also received data proposals from experts, inventory compilers, researchers. And then technical support unit, we conduct preliminary check of completeness of data information. And then we forward that proposal to editorial board for consideration. And at TSU, we also conduct literature search to identify data and for consideration by the editorial board. So in addition, the IPCC-TIFI, we organize annually expert meetings to collect data for the FTB. So all data proposals submitted by data providers, submitted by technical support unit, they submitted by the experts from expert meetings are considered by the editorial board for inclusion into the FTB. So the usage the FTB and data downloaded from FTB have been increasing. So here we see time series data on the unique visitors and data downloaded from the FTB. We see the significant, substantial increase starting from 2018. Okay. So a little bit about how to search, how to use the FTB. So FTB has several search options and several search criteria we have. So in this field, users can see status of their search and also users can to narrow down search results using the filter functions available. And search results can be exported, for example, as an Excel file. And then also you can look at more details of the data in the search results. So this is one of the example of the export file, exported from the FTB. So each data in FTB has its own ID, and for this data, this ID, you can see details. The details of data in FTB can be seen like this. So this is one of the examples. So we have been working on enhancement and improvement of the FTB. We released the upgraded version of the FTB in September this year. This upgraded version contains categories of the 2019 refinement, and it also has enhanced search and filter functions, and it also shows statistics of data we have in the FTB. So 2019 refinement categories included, and new criteria we have. And data statistics also users can see, and we have enhanced filter functions. So IPCC-TIFI organize the editorial board meetings annually. The most recent editorial board meeting was held in New Zealand in May this year. And we also the expert meeting on data for the FTB in parallel with the editorial board meeting in New Zealand. So more than 2,400 data were accepted from these meetings by the editorial board, and then included in the FTB. So the slide shows that a little bit more detail on the criteria used by the editorial board for consideration of the data proposals for inclusion data into the FTB. So this is the end of my presentation. I thank you very much.
Thank you very much, Suran. Do we have any questions on the EFDB? If not, I think we can move on to the IPCC inventory software. Sandro, please.
Yeah. Maybe first a word why in the methodology work of the task force inventory we had the FDB. We expect the FDB to be the database that the authors of IPCC needs to refine the IPCC default. This default need to be refined with time because condition changes. And to do that, they need large data sets. And this is the main challenge to produce an IPCC default, to have enough data to be analyzed and to produce accurate IPCC default. Now, why we have the IPCC inventory software in the methodology work of the National Task Force Inventory? Within the scope of the National Task Force or National Greenhouse Gas Inventory, there is the preparation, the production of guidelines, methodological guidelines, but also their operationalization in a software. So the software is the operative implementation of what is written in the guidelines. And this means that since the guidelines are based on good practice, they are not based on standard. A good practice are various interpretation, various ways to be implemented. The software is not so banal because you need to allow all this flexibility while be consistent with the famous 5 principles that are the basis of the greenhouse gas inventory, which is transparency, accuracy, consistency, completeness, and then comparability. So we are still developing the software because it takes time. And so it's a big piece of work. Now, in this software, we released the version 289. The version 289 aims to have all the methodological tiers and approaches for sectoral greenhouse gas emissions and removal estimates already in. We are still doing some further work to make those more accurate, to expand the flexibility, but especially to make the calculation consistent with what the UNFCCC requires, which are the famous UNFCCC reporting tables, which are in some degree consistent with the 2006 guidelines, but they go usually further in depth in terms of quantification of the source categories of the sources and sinks. Often the stratification that you find in the UNFCCC common reporting tables is that one of the 2019 refinement. So our software is composed is a 3-color software at the moment. You have the blue, which is the 2006 IPCC guidelines. You have a lilac that identify which elements comes from the wetland supplement. And then you have also magenta, which identify which additional elements comes from the 2019 refinement. While the wetland supplement has been fully implemented in the software, the 2019 refinement, no. Only those elements needed to allow the interoperability with the CRT tables, with the reporting tables for UNFCCC. Now, what is that? This one? Too much, huh? Yes. There is some delay. Okay. So the version allow you to estimate to produce the greenhouse gas inventory as a single aggregate national, or to produce an infinite number of disaggregation, region, province, project, whatever. Everything sum up to the national total. It allow then, because of that, it allow for each category to apply a single tier methodology or to apply different tiers to different subdivision of a category. It allow, because the need of to do the key category analysis, as Pavel said, it implemented the AR5 global warming potential, but the user may implement any other metric he wishes. There is a module that allow to build your own metric. In some cases, it's useful to see the differences between different GWP and different other metrics that are still under debate within IPCC. the UNSCC they established the use of the AR5 GBPs. The architecture will be these are the various building blocks. What makes this software extremely useful also for developing countries is the fact that you have a single database. Maybe I may also, yes. The software is based on a single database, is Microsoft Access in this case, and where all the data are stored. So it allows to deal properly with the data archiving. It allows to then avoid to lose data, maybe because of inventory compiler keep changing, or maybe because of failure or losses. Indeed, there's also a backup functionality. It keeps asking you to produce backup. The password that the security done by, sorry, the database that the security done by a password. Don't lose the password because it cannot be recovered. You need to be mindful that you shall never lose the password. The software has all the IPCC default already embedded. So when you do a calculation, you may either apply the IPCC default or you apply your own default. Or, and he has calculation worksheet for each and every category. Usually he has a number of calculation worksheet for each category. Because if you have a multiple IPCC tier methods, these tier methods are usually implemented with a number of worksheets. So in a category is likely to have, now we have an example, but it is a simple category. This is a nitric acid production. You see also in this case there are three worksheets because you may have different level of complexity. Each worksheet show you the yellow, in the yellow rectangle you have all the greenhouse gas inventory category. Then there you select which inventory you want to calculate. Then you have a subdivision. You see the kind of lilac, violet. There means that you may substratify your national estimates, and you may do whatever aggregation you wish. It's up to you. There is no limit. Then there are technology in this case, PCT estimated the emission according with the technology applied, but the user may input his own technology. Then you have all the default emission factors and parameters, or the user may input its own in this light blue rectangle, in those three columns. Then you input the activity data, and at the end, in the green cell, the software calculates the emissions. These emissions then are reported. IPCC software has various levels of reporting. The IPCC reporting is made by 4 different types of tables: the short summary, the sectoral table, and the background table. The IPCC also export in the non-annex 1 table for the UNSCC that were the requirement before the Paris Agreement. Those tables won't be anymore the requirement for developing countries because everybody now is requested to use the common reporting tables. And indeed, because of the common reporting tables, we are working on the interoperability. And now Lisa will show you some slide, which means that you calculate the emissions removal according with IPCC categories and methodologies. But then the software map all the information in the format requested by UNFCCC. So with the categorization of UNFCCC, and with the level of disaggregation that the UNFCCC requires. And this is made at once inside the software. Lisa will show you how. And so the software produces you a file that can be directly submitted to the UNFCCC, uploaded into the UNFCCC. We are also working a lot on the guidebook. Why the guidebook? Because of this flexibility, because all tiers are implemented, the software is not anymore so banal. So we found the need to produce a guidebook that step by step guide the user in using each and every worksheet to produce the estimates. We expect to publish next week the energy guidebook, which is the first. We already have a lender representation guidebook because lender representation is something. We have already a guidebook for interoperability. All these guidebooks are going to be revised with time. So the user are strongly invited to check time to time if a new version of the guidebook, like a new version of the software, has been released. This is the guidebook structure. You see, we have some flow chart that explain you step by step what you have to do, what is the level of disaggregation, and then which are the worksheets that you need to use. And now I pass the microphone to Lisa for the interoperability.
Thank you, Sandro. And I just wanted to highlight a work stream that we have been working on over the past over a year now, and working very closely with the UNFCCC Secretariat, and that's this work on the interoperability. As you know, countries are in the process now of preparing their biennial transparency reports, and in Glasgow, they agreed to these common reporting tables. The UNFCCC Secretariat presented on them last week and has been working heavily on the training of the reporting software. But also in that Glasgow decision, they asked the Secretariat to work with the IPCC and particularly on interoperability between the IPCC inventory software and the UNFCCC reporting tool. And this is really, really important. As Sandro said, for both developed and developing countries, it's an opportunity to actually use the software and all the benefits that it brings to calculate your greenhouse gas emissions for all categories that are required to be reported under the Paris Agreement, to calculate your emissions in the software, and then to prepare a file that can be uploaded to the UNFCCC tool and submitted. So it helps create this kind of institutional arrangement in your country, a database to save your data. It helps reduce errors. And so we've been working very closely with them to implement this. So the steps are interoperability. There's two sides. There's the IPCC inventory side, where you calculate your greenhouse gas emissions. We've prepared some visualization tables in the IPCC software that show, they visualize the common reporting tables of the UNFCCC. This is important because, as Sandra mentioned, it isn't a one-to-one mapping between the IPCC and the UNFCCC. A clear example is AFLU. The guidelines have AFLU, and the parties have agreed to report agriculture and LULUCF. So we wanted to show how all of the worksheets in the IPCC, what they will look like in the agreed CRT. So you can visualize it, and then you generate a file, and then carry it over to the UNFCCC. You can upload that file in the JSON format, and there submit your greenhouse gas inventory. I think an important point that came up in an earlier side event, and there was the question, can you do everything in the IPCC software? And the answer is yes. You can calculate all of your categories in the software, but the official submission will then go through the UNFCCC. So just to illustrate, and I will say we have a booth today, and so we can show you some more of this. If you're interested in the mechanics of how it works, I can just show you quickly here, but we're there and available and happy to talk further. But you estimate your greenhouse gas emissions. You insert your activity data. As Sandra mentioned, there's defaults in the software, or you can use your own country-specific factors using any method from the IPCC guidelines to calculate your emissions. And you can't see the number in the bottom, but that red box, I can tell you that number is the emissions that will then transfer over to the UNFCCC reporting tool. And then once you have estimated emissions for all categories, there's a functionality in the reporter, the export-import function up top, where you can export the tables to the CRT. And then you identify your data set, you name the years that you want to prepare for the UNFCCC, and you collect you collect the data. The software asks, do you want to populate the data? And what it does then is it takes all of the activity data, all of the emission factors from the underlying worksheets and maps them to the tables like this. So for those who are familiar with the CRT, these orange and white cells are the tables of the CRT. We have all of the white cells are information that you would enter in the IPCC software, and then this tool and then the CRT can calculate what your total greenhouse gas emissions are. So as a user, you would look at these tables, you would QC them, make sure that the data there are what you expect. You can do this right now. You could download the IPCC software and you could look at this for the energy sector, the agriculture sector, and the waste sector. We're working on LULUCF now, and it will be followed by IPPU. And that red box is the the data that carried over from the inventory software. There's a lot of other functionalities in this table that will help you complete other information that is required by the CRT, information on methods, emission factors. There are a number of, if a country says that emissions are not estimated, they're required to report an explanation in the CRT. You can do this in the visualization tables. You can also explain where you've included an emission estimate elsewhere. Also important there, if you have, as a developing country, used flexibility, there's additional information that should be reported, and that can also be added in this table. And then once you've done that, you've checked all of your sectors and you're ready to prepare the file for the UNFCCC. There's again a functionality where you basically select generate JSON. That's the file that can be used by the UNFCCC. You again indicate which years you want to transmit. Perhaps you want to do all years in the inventory software, but you don't want to report all to the UNFCCC. So you can select those, and then you generate that JSON file. And so that's half the story. That's the IPCC side of the story. That's how you generate the JSON file. And again, we've been working closely with the UNFCCC, and we're happy to demonstrate that. And in their trainings, they're also demonstrating this upload of the JSON file, so you can see how it works. I don't know if you want to. So. This is the website where you can download the latest version 2.89 of the software. There's multiple versions to download depending on your software. We can also help you. There will be multiple releases in the coming months as we move towards June 2024. Like I mentioned, the next one will be with LULUCF. No, it's old. Yeah, the demonstration can be at the booth. We're booth number 8. So yeah, thank you very much.
Thank you. Thank you very much, Sandro and Lisa. Do we have any questions or comments for Sandro or Lisa? Yes, please, in the front.
Yes, hello. So do you have a verification mechanism for the calculated reports?
Verification of the JSON file, you say?
No, the calculated.
Well, our software is supposed to be correct. In theory, it should be used for verification of national greenhouse gas inventory. Some bug may happen, but we're stand ready to fix any bug that can be identified. Actually, our software, for instance, for developer country, they usually use a number of files, routine, and so on. Using also our software could be a good verification instrument. So to compare what, according with the IPCC, they may get, what they get with their national specific methodology. The review process here we have a UNFCCC is better than goals. When you apply an IPCC method, you don't need to verify the IPCC method. On the contrary, you may use the IPCC method to verify a country-specific method. But it has a legal value, an IPCC method. Yeah.
We have, I think we have 10 minutes if there are any other comments or questions. Yes, please.
Thank you very much. This is Hugo Kanaya from Jamstack, committed to the SLCF type of emission inventory, and also expert meeting and the SLCF chapter in the AL6. And yeah, my question might be very general, but is there any regular opportunity to compare the national, sulfur GHG emissions with the, for example, the CEDS, the input of the emission of the CMIT type of the chemical, the climate system simulations for the potential consolidation of the IPCC level of the emission statistics.
Sorry.
I'm not sure I get the question, but if the question is about atmospheric measurements and so on, no.
Just a possibility of comparison of the national emission inventory that is developed here with the CEDS emission. That is the input to the climate model simulation that IPCC working group 1 estimate.
I now understand. But you need to compile a global, the software, when you start the software, you select your country or you select the world. So in theory, you may select the world, but then you need to input the data of the entire planet. I mean, there are some exercise like EDGAR of the European Union doing that. You should take the EDGAR database, input into the software, get the result, and then you may do a comparison. But be aware that the inventory software estimates just the anthropogenic component and not all the emissions and removals.
Okay, thanks.
Okay, then I think I think I should say that we have very good collaboration with the UNFCCC Secretariat, and we have to thank the UNFCCC Secretariat for this. And also maybe just on the software that we're working very hard, the TSU, Lisa, Sandro, on development of the software, but we could use help testing this software. So if you have a chance to download, please download the software and test it, and please let the TSU know if you find any bugs. But there's another question in the back. Who's last question?
Hello, my question is, how will the IPCC build capacities of countries, especially developing countries, on its tool?
Now, the IPCC, the task force, the technical support unit, which is the secretariat of the task force, is composed by 3 persons and 1 consultant. You see, the software is not the only activity. We have the methodology report, which is considered the most important. We have the emission factor database. We have the software. The world is composed by almost 200 countries. We are 3 + 1. So, but nevertheless, we are aware of this. So we are struggling to prepare and publish the guidebook. The guidebook is the first step. No, the first step is that users need to know the IPCC guidelines, otherwise you don't go anywhere. Then the manual of the software, because there are some general functionality, is important, but it's very small. It's not difficult. Then you need to go with the guidebook step by step. Then, if you have further questions, you ask us. But we are having conversation with some big capacity building player to stimulate their activity on this field, because we are very well aware of the needs. We are aware that it's impossible that we, as TSU, we satisfy such needs. I have hope that already next year something will start. Some of these big capacity building initiatives will start to provide some support, and this will be increasingly in the next year. So I'm quite positive for that. There will be support.
With that, I think I'll pass to my fellow co-chair to close our event.
Thank you, Takashi. First of all, I appreciate and thank you the experts from technical support unit of TFI. Thank you, Pavel, Suren, Lisa, and Sandro. Secondly, the work of TFI is basically to come up with methodologies and inventories in an internationally agreed way for GHG emission estimation and removals. It is a continuous process, as mentioned by Sandro. The first version of the software, IPCC inventory software, was released in 2012, and it was very basic, software. But over the period of time, it has developed its capacity that it can estimate emissions up to tier 3, and even with a mixed level, you can go with, for some sectors, with tier 1, some with tier 2 and 3. Same is the case with the emission factor database. It has improved over the period of time, and other methodologies. As mentioned by the speakers, that we have a lot of work ahead of us for AR7 cycle, particularly the development of methodology for SL short-lived climate forces and related interoperability of UNFCCC software with the IPCC software. So this is a continuous process, and we receive feedback from the end users. We have expert meetings like that one. With this, we close today's session with appreciation to the very limited team of experts we have in TSU, and clapping for our TSU. Thank you very much. With this, we close the session.